So let's move on to physics. Try problem solving. The problem situation says an aquarium is 40 centimeters long, 20 centimeters wide, and 30 centimeters high. With what force is the water pressing on the bottom of the aquarium? So traditionally, let's try different tools. We'll start from 3.5 version, then 4, and then Wolfram Assistant. Let's take into account that the problem situation asks about force that is pressing the bottom. So the force should be expressed in newtons, because if they ask for pressure, for example, that would be Pascals. Force is newtons, just to have a clue in what units should we get our answer. All right, change to 3.5 version, and then I will paste the problem situation here. Okay, pressure, force over area, that's right, volume, force mass times gravity, correct. Also the water exerts a pressure of 2940 Pascals. Yeah, but the question is not in the pressure, the question is force. But let's go a little bit above, and then we see force here as well, right? 235.2 newtons. So it has already calculated force, it understood the question correctly, however it did some redundant work with calculation of pressure. Now let's check if the force is correct actually, because I see that its chain of thoughts is right. Force over area, yes. This is pressure, so, and then on the other hand, how can we find the force? Force should be mass times gravity here. Okay. 24 kilograms is mass of water. How? Because of volume, 40 times 20 times 30. I will just pull out a calculator and do that quickly. So, well, 4 times 2 times 3 is 24,000, that's correct. So this is right, and this is milliliters, and this is 24 liters, that is 24 kilograms, because the density of water equals to unity, right? So I'll just go here, 24 times 9.8, and it's 235.2. All right, GPT 3.5 solved it correctly. So we see for this kind of task, GPT 3.5 is enough. Great. Let's switch to version 4. Again, the same problem. I actually see that the solution looks pretty similar to what 3.5 did. Okay, in meters, not in centimeters. That's okay. Okay, version 4 works a little bit slower than 3.5. We know that. Okay, now it launched code interpreter. Code interpreter takes some time to think. Yeah, 235. Yes, GPT-4 is also correct. Here we can open the code if you want. If you understand Python, you can analyze it, but it's correct, yeah. Okay, and finally, Wolfram Alpha. If you compare this value with 3.5 version, we'll see like it's a little bit different, right? So it could be just rounding error. It depends how many significant figures did they take into account, but that's still fine. All right, now let's go to Wolfram Assistant. We'll paste the same problem. What is this? I don't know, delete. Okay, let's just see how Wolfram Assistant thinks. Allow. Okay, the answer is density times gravity times volume. All right. Okay, 235.2, even closer to the answer by 3.5 version rather than 4. So we even may think that 3.5 version gave us more precise answer. So that's perfect. This kind of problem was easy for ChatGPT. All versions solved it correctly without any problems, unlike algebra or geometry, where we had different variants of solution and some of them were wrong. Here, all ChatGPT versions unanimously ended up with a correct answer. And that's awesome.